Hello again, higher algebra students, back here with lesson 3 from unit 6, looking at transformations and more specifically translations here in this lesson. We're going to look at horizontal translation, so you can see like this here where it shifts the function a certain number of units sideways. We have vertical translations, which you see here where it's just shifting a function up or down, or could combine the two and it could shift a function both up or down and over one direction or the other. So we'll look at all three here and we'll jump right into it. So transformation is a change in the size or position of a figure or graph. Again, here we're looking particularly or specifically at the position. We're not going to change the size yet in this lesson. And a translation here is a type of transformation that just slides a graph. Okay, again, slides it up or down, left or right. So for instance, if you look at these combination of functions here, naturally this first one is this black line down here. The second one, this red line, that +6, simply moved that same graph up 6 units. So for every single point here on this line, it just moved up exactly 6 units. Obviously, probably the most easy one to see would be right at the y-intercept there. But again, you could pick any point and the point right above it, and it would be moved up 6 units along that line. So we would say here the x plus 6 translates x up 6 units. So that is, again, just terminology for the translation. So translation of any function, excuse me, the h here, what you're going to see is this is our horizontal translation. Now, one thing to be aware of is that subtraction is already built in. So when you see subtraction, it's a reminder that it actually moves us to the right. If you see addition, it actually moves us to the left. So it almost seems counterintuitive there. And then the K, to move it up or down, gets tagged on to the end. So you see a couple of examples here. X minus 7 moved this 7 units to the right, whatever that graph was, okay? And the +4 at the end, a little more natural here, is the +4 is simply going to move us 4 units up, okay? Here's another one. You see the +2 to begin with here. So the +2, again, actually moves us 2 units to the left. So when you see the +2 in the parentheses like that, that's our horizontal translation. It's moving us to the left. And then there was a -6 there in the green. And again, the -6 meant we would move 6 units down because that's the one that's a little more natural. So again, vertical at the end, horizontal inside, and just make sure that you remember that that horizontal one almost works backward from what you would think. When you see -7, your mindset might be to go back 7, but in this case, it's 7 units to the right, and we'll talk more about that as we progress. All right, so here's an example with a parabola with a parent function of x squared. Okay, so again, the parent function of x squared here would show us that the original graph, again, that x squared parabola has the point 0, 0. It has the point 1, 1, and then -1 squared is also 1. Okay, 2 squared is 4, -2 squared is also 4, 3 squared is 9, -3 squared is 9. So again, this is what our parabola looks like. Okay, and this is just the y equals x squared graph. Okay, now what you're seeing from here to here again is a pair of translations. Again, within the parentheses, that's a horizontal translation. Okay, after the parentheses, that's a vertical translation. And probably the easiest way to look at this, aside from just using Notability to cut this graph and to move it, would be to redraw it, but start with a certain point. And probably the easiest point to start with would be that minimum point on that left graph. So we're going to find where the minimum point is on the new graph. Okay, so if we started right here, and here, that -4, again, that means 4 units to the right. Again, that's that kind of counterintuitive that subtraction actually means to the right. So that's 4 units to the right. And then the second one here is actually a -3. That's moving it 3 units down. Okay, so our new minimum is right there. So you can see what happened is we basically, here's our overall translation. Again, it happens with horizontal and vertical. So we had, again, one pushes us sideways and one pushes us down, but that's really just what it did. The combination of those two slid it kind of diagonally here. Okay, now we could actually put in values of x into the equation to finish the graph if we wanted to. Okay, so you can see this point right here is at the point 4, -3. Okay, so if we put 5 into our equation, it would be 5 minus 4 squared and then minus 3. So that would be 1 squared minus 3, which is 1 minus 3, which is -2. So that means that we would have the coordinate 5, -2. Again, this is just me putting 5 in for x. So the point 5, -2 is right here. But again, all I really needed to do is look back over at this graph and see that another point is 1 to the side and 1 up from my minimum point. And similarly, I'd go 1 to the side backward and 1 up. Okay? And then I went 1 more out and went 3 up. So I'd go 1 more out and 3 up on each side. Okay? And again, I could put x equals 2 and x equals 6 into my equation and show that the answer would be 1 in my new equation if I put x equals 2 and x equals 6 in there. But it's okay if you just follow the same format as you had in the original. Okay, next I go over 1 more and up 5, because it went from 4 to 9. So if I go over 1 more and then up 1, 2, 3, 4, 5, there's another point. Over 1 more and then up 1, 2, 3, 4, 5, there's another point. So what I've done is this is the exact same graph as the original, but just translated. Okay, I've moved it over 4 units to the right and down 3 units. And of course, the other way I could have done that is I could have looked at every single individual point and figured that this point right here moves 1, 2, 3, 4 units to the right and 1, 2, 3 units down, which is exactly where this point ends up. Okay, so the translation occurs to every individual point equally. It's just that you'll probably find 1 or 2 or 3 points to work with specifically and then redraw the graph in there. Okay, continue on here. Here's another parent function. This is the absolute value of x. And again, the absolute value of x, if I had to graph this, if I just put in the points, so I drew a little too big there, but if I put in the points -2 to 2 for x, absolute values would lead to just positive versions of all of those. So I'd have the point 0, 0, and then a point 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and so on. -1, 1, -2, 2, -3, 3, -4, 4, -5, 5. And so the graph of the absolute value of x looks like this. Okay? And that's something you'll be used to as you graph that more and more. So now again, let's use this minimum point right here, this one right here, and let's apply these translations. So the +4 here now again means that that point that was at the origin, at the crosshairs of our coordinates at 0, 0, that goes back 4 units now. So back 1, 2, 3, 4. And that again is because of the +4 that we see right here. Okay. Now the -1 at the end here, this now means that we're going to take this center and move it down 1 unit. Okay. So this black dot right here, and I'll turn that to be blue, that is our new minimum. Okay. Now again, for the graph of the absolute value of x, we just kept going up 1 and over 1 in both directions. So all I really need to do here is just keep going up 1 and over 1 in both directions. So there's a +1 slope going to the right and a -1 slope coming in from the left. Okay. So here is my new graph of the absolute value of x. But again, every individual point underwent a translation of 4 units to the left and 1 unit down. Okay, so that's our new graph undergoing, again, a vertical and a horizontal translation. So looking at these, what would each functional equation look like if it were moved 6 units to the right and up 2? Okay, so what we're doing essentially is, again, any horizontal translation is done within the parentheses. Okay, so 6 units to the right here means we're going to have some sort of minus 6. Again, that's what moves it to the right in the parenthesis. Okay, up 2 means we're going to have some sort of plus 2 at the end. So simply for this first one, our new function, instead of just x, would be x minus 6 in the parentheses and would be plus 2 after. Okay, that's the horizontal translation there. There's the vertical translation there. Okay, similarly here for the x squared, this is kind of like what we were working on in the example. Instead of just x squared, it's now in parentheses x minus 6, but then it's still squared because the x was squared. Now it's just subtracted by 6, and then we'd add 2. Okay, continuing on, the absolute value of x would now be f of x equals the absolute value of x minus 6, and then plus 2. So again, everything in this case, instead of inside parentheses, it's inside the absolute value. With the root of x here, the root of x would now be the root of x minus 6 and then plus 2. So again, the minus 6, that just means that went under the actual radical with the x. And that's what causes that translation, that horizontal translation. And then we add the 2 for the vertical translation. Okay? And it's probably not going to be surprising at this point, but the x cubed is a lot like the x squared, but we just have raised to the third instead of raised to the second. Okay, so there's your x minus 6 cubed, quantity cubed. Again, quantity means everything in the parentheses is cubed, and then plus 2. Okay, now we look at the challenge. So with the challenge, it's, again, a lot of the same. Now this is obviously a more complicated formula, but with the f of x, instead of just 1 over x, it's now 1 over x minus 6, because the x just gets subtracted by 6, or x minus 6, and then again, the plus 2 would be out at the end because that's our vertical translation at that point. So the minus 6 just goes wherever that x term is, and the plus 2 just gets tagged on to the end of it all. Okay? So when we create equations and we have these descriptions, you can see, you'll start to see this communication like translated down 7. Okay, so translated down 7, in this case, would just mean that we take the x squared and we subtracted 7. Okay, so the domain for the x squared was, as the graph looked like this, and it just continued to go off in this direction, the domain was really was negative infinity to infinity. Well, the domain remains negative infinity to infinity because there's no restriction on where it can go with the x's. Okay, and what happened here is when we translated down 7, all we did is really took the same graph but just moved it down 7 units. So the range used to be from 0 up, okay, in the old graph. Now it's from -7 up, and I accidentally drew a parenthesis instead of a bracket there, but our minimum now is -7, and it goes to infinity. And again, that range is because the range on the original green graph went down to 0 for the y values. Now the y values go down to a -7. Looking at the second one here, so again, now we are talking about the absolute value of x graph, and so I'll just go down here and draw that again just as a reminder. So the absolute value of x, again, the graph, the parent function just starts at the origin, 0, 0, goes up 1 over 1 in each direction. And now we're saying that we're translating it right 4 units. Well, by translating it right 4 units, let's take a look at what we do to the domain or range. So if we go over 4 units and put the new center here, or new minimum here, and draw this, Okay, when we look at domain, we're looking at what are the possible x values. Well, the original blue graph continued to go on in both directions forever, as does the red graph. So we have made no changes to the domain here, similar to the first one. That's still negative infinity to infinity. The range, again, it originally had a minimum of 0 for a y value. Again, range is y values. Okay, so it had a minimum of 0, and it would go up forever, just as it does now. So the range here has not changed one bit. That's still 0 to infinity, and 0 is included there, so it gets the bracket. Infinity, as always, gets the parenthesis. Okay, so that would be really no change in this one by translating to the right 4 units, because it does nothing to the x's, and we didn't move up or down at all, so it didn't change the y's or the range. The last one here, the root x. Okay, so as a reminder, the root x graph looks something like this. Okay, and now we've translated this one up 1 unit and to the left 6 units. Okay, so 1, 2, 3, 4, 5, 6. So essentially we've moved to this point, and again, the graph doesn't look any different, but the x values do. Okay, so what was a graph that started at the point 0, 0, now is a graph that starts at the point -6, 1. Okay, which means the domain here would actually start at a -6. Okay, now you do have to be to recognize here that the reason it can start at a -6, we are not taking the square root of a negative value, but the equation now looks like this. It's the root of x plus 6. And so if we put -6 in there for x, the root is still just a 0. And so our domain goes from -6, and again, it goes on forever to the right, so that's infinity. Okay, so don't be scared by having a negative value in there with a square root, because typically we can't take the square root of negative values, but again, we're adding the 6 under the radical. So we're already gonna, if we're at -6, we'll at least work back up to 0. If we're at -5, we'll obviously work back up to 1, and so on. Now the range here, the range did bottom out at a 0, okay, at the point 0, 0 on the original. Well, now it bottoms out 1 unit higher because of that translation up. And again, this would continue to go forever up and out. Even though it would take a long time to get to a big y value, it will get to a big y value as that x value continues to approach infinity. So the minimum for the range is going to be 1, because this is the lowest the y value will ever get right there. But the max for the y, or the max for the range, will still be infinity. All right, so that's just changing domain and range, or not changing it, depending on these translations for these graphs. We'll move on to our next topic here. Okay, now let's look at these same sorts of questions, but from a different perspective. And so the previous slide gave us the explanation of the translation, and then we had to write the equation. Now we have the equation, and what we're going to do is create descriptions here. So for instance, when you look at number 1 here, what would be the parent function that we are working with here is the first question. So this parent function would have been just x squared, okay? And now what did we do to that parent function is the next question. So obviously we subtracted 8 inside that parenthesis. And again, what does that mean? Well, if it's a vertical change, then it would have been plus or minus some value here. So this is a horizontal change. So is it to the right or to the left? Well, it's subtraction. And again, the formula is built in with subtraction. So this is actually a translation to the right. So it's f of x squared translated 8 units right. Okay, so if you go back and look at the previous slide, you'll see that this is the sort of explanation that the last slide had when we were given these problems. Okay, so number 2 here, in this particular problem, nothing was done to the root of x. Okay, so that would mean no horizontal translation, but there is a plus 10 at the end. So the second one, the parent function here is root x, and this would have been translated 10 units. And again, this one just works with the plus or minus as it is. So this would be 10 units up since it's a plus 10. Again, if it's inside the parenthesis here, it kind of works opposite of what you would think. And for the vertical translations, it works exactly as you would see with subtraction or addition. The third one here, so the third one you can see was cubed to begin with. So the parent function here would have been f of x equals x cubed. And you can see on this one that there was both a horizontal translation and a vertical translation. So this would have been x cubed translated 3 units to the, and again, this is opposite what we saw in the first one now. The first one was minus 8 and went to the right. So this is plus 3, so this would be to the left. Okay, so x plus 3 means 3 units to the left, and 2 units down because of that minus 2 at the end there. So, so this had 2 translations with it. And again, this would be explaining, creating the description of the translation. All right. So really quickly here, as we look at just a couple graphs to end it, when you look at this graph, one thing that's good to know is what would be the parent function here. And hopefully by now, you're comfortable looking at this graph and thinking, okay, the parent function on this one must have been a root of x, okay? Now, what did we do here? We took a graph that usually starts at the origin and goes like this, and we moved it 3 units to the right, okay? So 3 right. So what would that look like? Well, 3 units to the right then would be our original x, but now minus 3. You can put parentheses there if you want to. X minus 3, again, all under the radical, okay? If I would have put root of x minus 3 like that, this would be 3 units down, okay? But we want 3 units to the right, so we don't want this here, okay? So this is what moves us 3 units to the right. And as we look at this in terms of our new domain and range, the domain, again, is all the x values, and the x values started at 3. So that would be the minimum, and it looks like the x values are going on forever to the right, so the x values go on to infinity on the right side. The y values, again, they stay bottomed out at 0, so this is for the range, so this would be 0, and again, over time, they would also find their way to infinity in terms of what the max y value would be. Because even though they don't get there as fast as x when we take the root, if x can keep getting bigger, then y can keep getting bigger. So this would be the new domain and range. And again, from the graph, most importantly, writing the new equation that stemmed from the parent function to begin with. So one last one here. Again, hopefully here you look at this and think of the parent function being the absolute value of x. Again, the only parent functions we really talked about are x squared and maybe x to the third, and then the absolute value of x and the square root of x, okay? And so this one here is the absolute value of x. And in this case, we did not move it to the right or left at all, because again, the original equation is down here like this. And so you can see we just moved it up, okay? So our new equation, we would still just have absolute value x because we didn't move it to the left or right at all. But we did move it up 1, 2, 3, 4 units. So the vertical translation would be the plus 4 at the end of the equation. Okay, again, nothing to the inside of the absolute value because anything we do in there would move it left or right. Okay, and our domain again, as we look at the possible x's, well, if this keeps going that way and this keeps going that way, then the x's would be negative infinity to infinity. The y's, though, in this case, they originally bottomed out at 0 and then went up forever, okay, eventually. But now they bottom out at 4, okay? So our minimum for our range would be 4. Again, these are x's and these are y's, Okay, so our minimum for our y's would be 4, and our max for our y's would be infinity, because this would eventually just keep going up and up and up. So that's our new domain and range, and again, our new function after the translation. Thank you for watching, and as always, ask questions if you have them. Take care.